Good day to all. Welcome to LBV Gmath 3-1.1. I am Engineer Peter Benjamin B. Obiano, your lecturer for this video. Today, we will be starting a new topic. For the next videos, we will be talking about propositions. Right now, we are on the first topic under Part 3, Logic, the third part of our discussion on General Mathematics for Grade 11. This video addresses the most essential learning competency, which is to learn how to distinguish between simple and compound propositions. For our topic outline, first, we will be defining what propositions are, and then we will be differentiating simple and compound propositions, and lastly, we will take a look at the types of compound propositions. At the end of the video, I hope that we will be able to define what propositions are, differentiate between simple and compound propositions, and lastly, identify the different types of compound propositions. Alright, let's start with our discussion. What are propositions? Before we define what propositions are, let us first go back to our elementary English. Let's have a review on the different types of sentences. Let us start with the declarative sentence. What is a declarative sentence? This is a sentence that makes a statement or expresses an opinion. Example, we have the following. First one, I want to become an engineer. Now this makes a statement. Another one, we have this one. My brother is good at mathematics. Now this one expresses an opinion. Both of these are declarative sentences. And of course, I believe you still know this one. Declarative sentences end with periods. Next, we have the imperative sentence. This is a sentence that gives a command or make a request. Example, you have the following. Go to your room and study. Now this one gives a command. The second one, we have this. Please go to your room and study. Now this makes a request. So these are examples of imperative sentences. And just like declarative sentences, they end with a period. Third one, we have the interrogative sentence. Interrogative sentence is a sentence that asks a question. Example, you have this one. When are you going to finish your assignment? One can easily tell that it is an interrogative sentence since interrogative sentences end with a question mark. Lastly, we have exclamatory sentences. Now, an exclamatory sentence is a sentence that expresses strong emotions such as happiness, anger, surprise, and excitement. Example, we have this one. I got a perfect score on my exam. Exclamatory sentences are also easily identifiable since they end with an exclamation mark. Now, let us go back to our actual topic. What is a proposition? A proposition is defined as a declarative sentence that is either true or false, but not both. There are two key parts that make up a proposition. First, it should be a declarative sentence. That's the reason why we reviewed the types of sentences, so that we will be refreshed what a declarative sentence is. Now, most of the time, propositions tell a statement. Aside from being a declarative sentence, we have another condition for it to become a proposition. It says here that your declarative sentence must be either true or false, but not both. Now, this condition is actually very important. Not all declarative sentences can be considered as a proposition. So, it means that your sentence must be easily identifiable as it is true or it is false. Now, what does it mean exactly that it is either true or false but not both? It simply means that if you say a proposition, we must be sure that what you are saying can be considered entirely true, or what you are saying can be considered entirely false. It means that we are sure that it is a true statement or a false statement. If we have a doubt about a certain statement being true or being false, or if a statement sometimes can be true or sometimes can be false, then what you got is not a proposition. Don't worry, we'll have examples later. So that we can familiarize ourselves on whether a given sentence is a proposition or not, let us perform this exercise. Let us identify if the following is a proposition or not. Let's start with the first one. Studying hard caused Alberto to pass the exam. Now, the first one is a proposition. As you can see, this is a declarative sentence. And it's telling us that Alberto passed the exam. What about the second one? Watch out. Now, this is not a proposition. Why? This is not a declarative sentence. It is in fact an exclamatory sentence. Third one, how much water do we need? Also, this is not a proposition. Once again, because this is not a declarative sentence. Specifically, this is an interrogative sentence. Next one, 5 plus 10 is equal to 11. Now, take note, this is a proposition. Kindly remember, all number sentences are propositions. Number sentences are like this one. So, let's say you have 5 plus 10 equals 11. Or, let's say you'll make another one. Let's say 1 plus 5 is equal to 6. 7 minus 2 is equal to 5. So those are number sentences, and they are propositions. Next, x plus 3 is equal to 5. Now take note, this is not a proposition. Why? Why is it not a proposition? Remember that the second condition for it to become a proposition is it should be clear that the statement is true or false. As you can see, the value of x will dictate if the equation will become true or it will become false. Since it can be true or false depending on the value of x, then it can be either true, it can be either false. We don't know. We cannot say. So we are not sure that it is true or it is not false. That is why this is not a proposition. Let's say x is equal to 2. So if x is equal to 2, you have 2 plus 3 equals 5, then the equation becomes true. However, if we choose any value for x other than x equals 2, let's say you put here 1. 1 plus 3 is equal to 5. 4 is equal to 5. So definitely, that will become false. If you encountered an equation, take note, that is not a proposition, because it can be true, it can be false, depending on the value of x. So that is not how a proposition should be. What about the sixth one? X plus 3 is equal to 5 when x is 2. Yes, we have an equation. However, it was specified what is the value for x. Now, is this statement true or false? Of course, if you're going to evaluate it, if x is 2, you will be satisfying 2 plus 3 equals 5. Therefore, this is a true statement because it is true that when x is 2, x plus 3 is equal to 5. Since this is definitely true, then this is a proposition. Alright, so I hope it's clear to us if a given statement is a proposition or not. Let's have one last example for this exercise. Your answer is wrong. What about this one? Okay, this is not a proposition. This is actually what we call a paradox. Again, if the statement is true, it should only be true. It is clear. There is no conflict that what you're saying is true. If it is false, then it should only be false. Now, you said that your answer is wrong. What if you say that this statement is true? So let's say you say, okay, this statement is true. If this is true, then you are saying that the answer is false, that the answer is wrong. Now, if you assume that the statement is false, if you say that this statement is false, then this means that the answer is correct, since this is false. This is a paradox, and that is why it is not a proposition. So again, paradoxes are not propositions. So again, all number sentences are propositions. Simply equations with no statement on what the value of x is, they are not propositions. And a paradox is also not a proposition. Again, a proposition is a declarative sentence that is either true or false, but not both. Now that we have known how to determine if what is given is a proposition or not, let us now discuss simple propositions. Now, what is a simple proposition? A simple proposition is a statement that is singular in thought and conveys one thought only. Simple propositions do not contain any other propositions as a component part. Example, we have the following. 3 minus 1 is 2. 7 is an even number. The flower is blue. The square root of 4 is 2. As you can see, from these 4 statements, we can see that only one thought is being conveyed. So these are examples of simple propositions. Let us move on. Simple propositions are denoted by lowercase letters such as P, Q, R, S, and so on. Usually, in logic, the commonly used representations for simple propositions are P, Q, R, and S. But of course, you can use other letters if you want. Now, propositions are denoted by lowercase letters just to make things simpler. Example, let's say you have the proposition P, which says the product of 8 and 2 is 16. So let's say you were asked, okay, kindly make a conclusion. Can you make an observation out of this proposition? Is this true or is it false? Is it true that the product of 8 and 2 is 16? Yes. That is why you can just say P is true. So most of the time, variables or lowercase letters are used just to make statements simpler. Instead of rewriting the entire proposition, just say, okay, the proposition P is true. Let's say you have this one. The sum of 8 and 2 is 11. And let's say this is assigned as proposition Q. Once again, if you were asked, all right, is this proposition true or not? Is the sum of 8 and 2 11? Of course, it's false. Thus, you can just say Q is false. Let us now go to compound propositions. Now, what are compound propositions? These contain two or more propositions. These propositions are put together using logical operators or connective words such as and, or, if, then, and others. So, if you have a proposition and you saw the words and, or, if, then what you have is a compound proposition. The following are the different types of compound propositions, along with their logical connective that represents them. We also have here the symbols associated with each compound preposition. In the next video, we will be learning how to symbolize prepositions. For now, let us make ourselves familiar with the different symbols and words associated to each compound preposition. Let's start with the negation. Now, one way to distinguish that what you have is a negation is the word not. So if let's say you have Ben is not cooking. So you might say that is a negation. Aside from that, you can also use the words it is not the case that. So if you want to make a negation, you can just put it is not the case that before the original preposition. Don't worry, we'll have examples later. Now, the symbol that is used for negation is this and this. Most of the time, especially on textbooks, usually this one. The second type of compound preposition is what we call a conjunction. Now, how can you distinguish that what you have is conjunction? Or how can you make a conjunction? Well, the word that is usually used for conjunction is the word and. So if you want to take the conjunction of two prepositions, just connect them with the word and. As for the symbol used for conjunction, we have this one. Next, we have disjunction. In order to create a disjunction or to notice if what you have is a disjunction, we have the word or. So if you want to make a disjunction, get two prepositions and connect them with the word or. The symbol used for disjunction is this one. Next, we have the conditional preposition. Conditional prepositions are noticeable because of the words if and then. So let's say you encountered if you have this, then this will happen. So once you read the word if, something, and then something, then what you have is a conditional preposition. The symbols used for conditional prepositions are this one and this one. Most of the time, it's the single arrowhead. Lastly, you have the biconditional preposition. It is if and only if. So if you read if and only if on your proposition, then what you have is a biconditional statement. As for the symbol that is used for biconditional prepositions, it's aligned with double arrowhead. So these are the types of compound prepositions with their connective words and the symbols that usually represent them. Let us now discuss each compound preposition in detail. Let us start with negation. So a negation is a statement that exactly expresses what it would mean for the statement to be false. So basically, you are reversing what a statement says. If P is a statement, then the negation of P is not P. In terms of symbolic illustration, the negation of P is represented as either this or this one. Again, on textbooks, it's usually this. Though you can also find sources that use this notation. For negation, if your original proposition is true, then, of course, your negated proposition is false. Of course, it works the other way around. If your original proposition is false and you get the negation of that proposition, then, of course, the negation is now a true statement. Let's have an example. Let's say the original proposition, P, is Albert is good at mathematics. Now, if you want to get the negation, then you can do this one. Albert is not good at mathematics. So just place the word not. If you do not want this, you can also do this. This is also possible. It is not the case that Albert is good at mathematics. So there are actually many ways to tell that this is the negation of the original. However, the commonly used are the one that simply uses the word not and the one that uses the words it is not the case that. Next, we have conjunction. Now, let P and Q be propositions. The conjunction of P and Q is the proposition P and Q. The conjunction of P and Q can be denoted by this symbolic illustration. P and then the symbol for conjunction and then Q. The conjunction of P and Q is true when both P and Q are true, and it is false if one of P and Q is false. So if you want that your conjunction to be true, both P and Q must also be true. If one of them is false, then your conjunction is automatically a false statement. Example, yesterday it's Monday and tomorrow is Wednesday. So this proposition consists of two simple propositions. One is yesterday it's Monday, and the second one is tomorrow is Wednesday. So you have two propositions connected by the word and. Another example, the sun is shining, but it is raining. Now take note, aside from the word and, we can also use the word but. Take note, for logic, the word but is the same as and. So you can treat them interchangeably. Though, of course, use the appropriate word depending on what you are trying to say. So you have here two seemingly contradicting statements. That is why it is better to use the word but. But, of course, you can use the word and if you want. Anyways, we have two propositions here. The first proposition is the sun is shining. The second proposition is it is raining. So you have two propositions connected by the word but. So this is a conjunction. Next, we have disjunction. Let P and Q be propositions. The disjunction of P and Q is the proposition P or Q. In terms of symbolic illustration, the disjunction of P and Q is denoted by this. So this is P or Q. The disjunction of P and Q is false when both P and Q are false. It is true otherwise. It means that if you want that P or Q becomes false, then both P and Q must be false. If one of the two or both is true, then your entire disjunction is also true. Example, students who have taken calculus or computer science can take this class. So as you can see, this proposition consists of two simple propositions. One proposition is students who have taken calculus can take this class. The other proposition is students who have taken computer science can take this class. So as you can see, you have two propositions connected by the word or. What you have is a disjunction. Next, we have the conditional, or on other materials, it's called implication. So let's say you have the propositions P and Q. The conditional statement, if P then Q, is the proposition if P then Q. So again, this is the symbol used for conditional propositions. So one way of reading it is if P then Q. Now, a conditional proposition has two parts, the P and the Q. Now, if this is your arrangement, then P is what we call the hypothesis or antecedent or premise. So P is whatever proposition that is in between the words if and then. Q, on the other hand, is called the conclusion or consequence. Again, if this is how you arranged your proposition, then Q is whatever proposition that is found after the word then. So again, whatever the preposition that is in between if and then, that's our antecedent, and whatever preposition that is found after the word then that is our conclusion or consequent. Now, the condition statement is false when P is true and Q is false. It is true otherwise. So again, the conditional statement if P then Q will become false if P is true but Q is false. Don't worry, on the next video, we will go in depth on the discussion for conditional statements. For now, let's just familiarize ourselves with the parts of a conditional proposition. Let's have an example. If you get 100% on the exam, then you will get an A+. If you are going to, let's say, identify what is the antecedent here, again, the antecedent is this one. You get 100% on the exam. What is the consequence? The consequence is this. You will get an A+. So this a conditional proposition. Now, aside from the format if P then Q, there are other words, there are other ways to express a conditional statement. So again, this is the commonly used arrangement. Aside from this, you can also have this. Again, for these examples, P is the antecedent, Q is the consequent. All right? So aside from this, you can also say this one. You can also say this one. You can also say that Q if P. You can also say Q when P. Q whenever P. Q is necessary for P. Q follows from P. P implies Q. P only if Q. So those are the different ways on how to express conditional propositions. All right, let's now go to the last type of compound propositions. You have biconditional or by implication. Let P and Q be prepositions. The conditional statement with its symbolic form as like this. So again, if you saw a line with double arrowheads, then that is a biconditional proposition. Anyways, if you're going to read this one, this is P. So this one. So this is P if and only if Q. The biconditional statement is true when P and Q are both true or if both are false. The conditional statement is false otherwise. So again, for biconditional statements, it is true when both P and Q are true or both P and Q are false. If one is true, the other is false, then your biconditional statement is false. Let's have an example. You can take the flight if and only if you buy a ticket. So you have here, if and only if. This is a biconditional statement. So again, if let's say this statement is true, then both propositions must be true. It means that you can take the flight and you bought a ticket. Or it can be also the other way around. You bought a ticket, that is why you can take the flight. So if this is true, then both propositions are true. Now, if this is true and one is false, then the other must also be false. So let's say if you did not take the flight, then it just means that you did not buy a ticket. Again, it can also be the other way around. If you did not buy a ticket, then you will not be able to take the flight. So again, if this is true, then it's either both are true or both are false. So that is biconditional propositions. Now that we have defined the different simple and compound propositions, let us now try to classify the following propositions. Identify each proposition as simple or compound. If it is compound, identify if it is a negation, conjunction, disjunction, conditional, or biconditional. Alright, let's start with this one. My sister took her bachelor's degree at Manila. As you can see, this proposition only has one thought. Thus, this is a simple proposition. Second one, I woke up late, but I still arrived early. As you can see, we have the word but. You have two propositions connected by the word but. This is a compound proposition, specifically a conjunction. Number 3, either he studies his lessons or watches a movie with his friends. You have two propositions here. He studies his lessons. The other one is watches a movie with his friends. So he studies his lessons. He watches a movie with his friends. Two propositions connected by the word or. Thus, what you have is a compound proposition. Specifically, it is a disjunction. Next, you are entitled to a free movie ticket if you are a member. So as you can see, we have the word if here. Thus, this is a compound proposition. Specifically, this is a conditional proposition. Number 5, a number is divisible by 2 if and only if its ones digit is divisible by 2. So you have two propositions. A number is divisible by 2. The other one is its ones digit is divisible by 2. So you have two propositions connected by the words if and only if. Thus, what we have is a compound proposition, specifically a biconditional proposition. Number 6, Harry loves spaghetti or Grace loves macaroni. You have two propositions here. Harry loves spaghetti and Grace loves macaroni, connected by the word or. Therefore, what we have is a compound proposition, specifically a disjunction. Number 7, the sun is found at the center of the solar system. Now, this one only conveys one thought. Thus, this is a simple proposition. Number 8, Gabby can sing and Bea can dance. So you have two propositions. One is Gabby can sing, the other is Bea can dance. They are connected by the word and, therefore, you have a compound proposition, specifically a conjunction. Number 9, the home team wins whenever it is raining. So again, you have here two propositions. The home team wins, and the second one is it is raining. They are connected by the word whenever. So this is a compound proposition, specifically a conditional proposition. Lastly, you have this one. You can reach your goals if and only if you will work hard. So you have two propositions here. You can reach your goals, and the other one is you will work hard. And they are connected by the words if and only if. Thus, what we have is a compound proposition, specifically a biconditional proposition. All right, so I hope that we were able to discuss the difference between a simple and compound propositions. All right, so we are done with our video. I hope that we were able to learn, we were able to define what propositions are, we were able to differentiate between simple and compound propositions, and lastly, I hope that it is clear to us how to identify what type of compound proposition is presented to us. So we are done with LBV 3-1.1. Next will be 3-1.2. In that video, we will be learning how to illustrate and symbolize propositions. I would suggest kindly memorize the different symbols that represent each compound proposition. For additional lecture, you may refer to Chapter 6 of Queck's book on General Mathematics. God bless and see you on the next video.